This lab, we call it Computer Integrated Manufacturing and Automation Lab manual. And mm, in this, you will be uh, doing the programs for which is which is controlled numerically by the computer, and we call it as a CNC. So computer numerical control. So in this case, for your lab, there are total 12 programs. Out of 12 programs, 6 programs are done in a capsmil and capstar, and another 6 are done in a NC turn and NC mill. So already you know the meaning of milling and turning. So in turning, the workpiece will be rotating and against the tool path, and the tool will be fed against the rotating workpiece so that it cuts the material. So here there will be 2 axes now in a turning. One is a tool path where it is moving in a perpendicular direction, and another one is a rotation of the tool, rotation of the workpiece. So that will cause the material to cut, and it will give a shape based on the tool movement. Okay, so to start with, I will start from scratch. So let me close the software first. So to start with, there will be a software called as a NC. If I go to all programs, and here it will be in a CAD-M, and under that you can click on a capsmil 8.1. Capsmil 8.1 is the
Sir,
software.
we are not able to see, sir.
Oh, okay. 1 second. I'll share the content. Okay. Now you are able to see it,
Yes, sir.
the screen. Okay. So what the thing here is, like there will be a software called as capsmil, and here go to all programs, under CAD-M there is a folder called as a capsmil. So under that there will be icon here at the bottom. At the bottom of the taskbar there is a icon of milling. So if I click on that icon, the software will start. A window of a software will come. So this window we call it as a capsmil window, and it pops up with a one startup window, and under that startup window you click on this create a new part. Okay, so then you say okay. So once you click on the create new part, it will ask for the setup data. So under setup data, you have to select what is the unit that you are maintaining. So here units, there are 2 options. One is mm and inch. So click on the mm. So it will set the units as a mm. And under the workpiece material, there are so many materials under that. So under that you can select any of the material which we call it as a raw material. So here I have selected a cast iron alloy, medium hardness. Okay, then I will say okay, and rest all you keep as it is. Don't change any of the this one. But here there is a something called as a clearance Z. So that will give actually the height, the clearance that exists between the tip of the tool and the work table, or the bed of the machine. So that way is called as a clearance. In the sense, if you see here, this top portion will be the zero position of the tool tip, and the clearance between the table and that tool tip is around 100 mm is given. You can change this value at any point of time, but I will keep these things as a default, and I'll say okay. Once this is done, I have to create a geometry. Now to create a geometry, let me explain you what geometry I will be drawing. So I'll start with the PPT. So if I go here, if I take a top view, so the top view, the geometry will be given for you. The geometry, this one will be, drawings will be given to you. And this length is 200 mm here. And the height or the breadth, you can say, is 150 mm. Okay. And now this has to be, I'll draw the side view. Side view is something like this. Side view. So the depth is, that is height is 75 mm. So this is 75 mm. Now you should, you can imagine the block how it looks like. So in the top view, it is 200 mm by 150 mm, a rectangular shape, and depth is 75 mm. And I have to drill the holes in a circular pattern. Like if I insert a circle, so let me insert the circle. You're able to see it, right? So I'll just change the, okay. Now, so this is a circle, like we call it as a pitch diameter of a circle. Okay. Now, on the circumference of this circle, there will be a points. There will be a points. Around the 12 points are there, and those 12 points are that will give the reference point to drill the hole at that point. Okay, so I'll make this as, let me let it be like as colored. Copy paste it. Okay, now if I take all this, so if I keep all this circles as shown here, so this is how it looks like. Okay, so in the sense, this is a block, and the block I have drawn a pitch circle diameter. On those pitch circle diameter, I have to create a hole of certain diameter. The diameter of this small hole is 10 mm, and it has to be drilled up to a depth of, say, around This is the side view I am showing. Let me make it as like this. So if I take a section, cut here, if I cut here, I can see the hole, and the depth of this hole is 32 mm or 30 mm. Okay. Now I want to simulate this in a caps mill. Okay. So this is the problem definition. To do that one, first what I have to create is I have to create that blank, this blank of a 200 by 150 mm and depth of 75 mm. So for that one, I have to go to this geometry. So what we have done till now, I have created a new part, and under this I have selected some material, whose material I have selected it as cast iron alloy medium hardness, and the unit is mm, and the rest of the things like a clearance and all I have kept as it is default, and I will say okay. Then I'll give us some file name for this one. I will save it as some file name. I will call it as plate 1. Okay, I'll say plate 1. So it will save the file as a plate 1. Now after that I have to create that geometry. To do that, go to the geometry here. If you can see here at the bottom left corner, there are three things. One is called as geometry, another one is called as a machining, and the tool path. So I will be using all these three parameters or the icons for creating a geometry, for applying the for creating the operations, and then for generating the tool path. So I'll go to this geometry. Under the geometry, you go to draw. Under the draw, you select shape and rectangular with the center, length, and a width. Click on this. So a new window pops up, and it will ask for what is the length. So the length is 200 mm and breadth is 150 mm. And there are also some of the things like corner radius and rotation angle. So as of now, I will keep it as 0, and I'll say okay. So when I have created that geometry, you can see a cyan color rectangular box that is created, but it is asking for something called as a select the center point of the rectangle. So I will say 0, 0. So it is asking x, y. So I will say it as 0, 0 and say done. So you can see that the rectangular box gets fitted into the coordinate system. And if you want to zoom it, go to view and say zoom all. So you can see that a rectangular cyan color box is created. In the sense, only a rectangular 2D section is created. Still the depth is not given. Okay. So now if I want to give a depth, I should go to before that one, I need to create a circular geometry, right? The circular geometry was this kind, like a PCD we called it as. So to draw the PCD, let me refresh it. To draw the PCD, I'll go to draw, and under that I will say point patterns, points on a circle. Click on the points on a circle, and it will ask what is a PCD. PCD stands for pitch circle diameter. I will say 100 mm, and number of holes I want to create is 12. So I will give a 12 as a number of holes, and I'll say okay. Now it has created 12 holes. You can see that they are of blue color, but I don't think you can see that in on your system. But points will be created. It will be appearing now. I'll say where is the center of that PCD. I'll say 0, 0. Okay, and say done. So once that is done, 12 points are created on a PCD of a 100 diameter. So after that, I have to create a blank that is the thickness I want to create. I'll say again, zoom all. So I'll go to draw. This time I will select as a define blank. See, what I have done till now is I have created a 2D section of a rectangle and then I have created a 12 points. After that, I'll go to draw and select a define blank. So when I say a define blank, it will create a 3D model of this one. See, now a new window pops up and already I have created this top view, that is rectangular section I have drawn. Only the thing is Z is missing here. The depth is missing. That depth will be given here. So if it has to select a contour that I have created, I have to click on this select contour. Click on this select contour and then it is asking select a contour. So click on this cyan color rectangular box. Now when I select that one, you can see that the maximum and minimum coordinates got selected. So maximum x is 100, maximum y is 75. Similarly, the minimum x is minus 100, minimum y is minus 75. Now the blank thickness I will give it as 80 mm. So I wanted a 75 mm blank, but I want to take the blank as a 80 mm so that I can remove the 5 mm using a face milling. So I am keeping extra 5 mm thickness extra on the blank. So I will give it as 80 mm. And where does the Z coordinate lies? It lies at minus 75 mm. So minus 75 mm means if the tool tip is here, from there, if the tool tip is on the top of this blank, then if I say that as a 0, the downward direction is in a negative direction. So I have a minus 75 mm depth so that it reaches the table. So I have to feed this as a minus 75 in order to say where the Z coordinate lies. So I'll say OK. Now, once this is done, I have created the blank and where are the points that I want to create the holes. So after defining all this, I have to go to a machining. Okay, go to machining. That is the second option, the second icon from the geometry on the left bottom corner. So click on this machining, and under machining, I have to first create a milling. So here at the top, you can see a machining. Under machining, there are different operations like creating a hole, milling, and single motions, sub program, and all. So under this, click on this milling and go to a face milling. Under face milling, I have to pick the tool. Which tool I want to pick? So go to new tool. So under the tool, here you can select. There will be a number of tools here. So I can either select from face mill, end mill, form mill, and all. So under face mill, I will select face mill square bottom. Under that, you can select what diameter of the face mill you want to have. I will select 125 mm. It is up to you to select which tool you want, but I am selecting it as a 125 mm diameter face mill. Then I'll say OK. Now, once I select the tool, it is asking on which contour, on which material I have to do the face milling. So for that, it will ask which geometry. I will click on this rectangular box, and here I will select a rectangular with a center point, length, and a breadth. Click on this and say OK. And here it will say how much of the material has to be removed. So under the material thickness, I will give as 5 mm. Okay. So here I will give it as a 5 mm and I'll say okay. Okay. So once I select the tool, then where it has to machine, on which part and all, then it will ask what is the tool path. So there you can see a 4 circular positions of the tool tip. I can select any one of the circular part. So click on this circular part and automatically it will choose from where the tool should start machining. Okay. So once the face milling is done, the next operation is I need to create a holes. Go to machining, holes, and under the holes you can go for a drilling. So again under drilling I have to go for a new tool path, new tool, select a new tool, and under this you can select a drill tips. I will select a twist drill, and since I want 10 mm diameter hole, I will select something around 9.8 diameter 9.8 mm diameter twist drill, and I'll say okay. So another 2 mm I want to retain it so that I can use a rimmer to remove the 0.2 material, 0.2 mm material by using a rimming operation, because rimming operation will help to create a smoother section of the hole. Okay. Now it is asking where all I want to create the holes. So already I have created 12 points on the circular PCD, that is pitch circle diameter. I have to select any one tool, any one point of that. So I will pick on that point. So it turns to a red. Once it is picked, it turns to a red. It means that it has picked all the points. Then I'll say done. So once it is done, it is asking, do you want to omit any holes? Why it is asking means, suppose if I don't want to create all 12 holes. Instead, I want to create some 6 holes with a 32 mm and other 6 holes with a say 20 mm depth. So in that case, I should direct the system so that it picks the right hole position. So it is asking, do you want to omit any holes? Currently I want to create all 12 holes with a 32 mm. So I will say I don't want to omit any of the things. I will say no. So once that is done, it will ask what depth of hole I want. I will say 32 mm, or I'll give it as a 32 mm depth. So you can see the tool depth and all. So 32 is from the base of this cone to the height. So in the sense, if I see overall depth of the tool tip, it is at a 34. So automatically it will calculate what is the cone size. The software will automatically calculate the what is the cone size. So here I have given 32 mm depth, and to that some 3 mm will be the cone size, the depth of the cone. Okay. So I'll say okay. Now I have created only the holes. Now I have to create another operation wherein I want to make those holes smooth. So that can be done by rimming process. Again, I will go back to the machining and I'll go to holes, and under the holes there is an option called as the rimming here. So select the rimming. So again I will select a new tool here, and here I will pick the tool from the rimmer, and this time I will select a 10 mm diameter rimmer. Okay. So always it should be the in a sequence. Like if I create a rimming operation first, your tool will break. So the first operation should be what? The drilling using a twist drill. Then I should go for the rimming. So then only there won't be any problem with the tool breakage and all. So you should know what process or what operations I have to carry in a sequence so that the tools or the workpiece is not get damaged. So I'll select a 10 mm rimmer and I'll say OK. So again, it will ask which all are the holes that I want to select. So I will again select the same all 12 holes and I'll say done. So I don't want to omit any of the holes. I will say no. So again, here at depth, I will give it as 30 mm because 32 mm was my twist drill and there was a sank involved in it, like the cone, and there the chances of having more material will be there. And if the material is more, the rimmer cannot remove the more volume of the material because it has its own drawbacks. So here I will give a depth as 30 mm instead of 32. So I will say OK. So once this is done, my machining operations are created. So in a nutshell, what I have created till now is, first I have created the geometry, cross section, then I have defined the blank, then I have created where all the holes has to be created. So after defining the geometry, then I went for the machining process. Under the machining process, I am carrying out three operations, machining operations. One is called as a face milling, and second one is drilling with a twist drill, and third one is a rimming process or using a rimmer tool. So once this is done, I have to go for the tool path. So again, you go for, you look at the bottom left corner, there is a icon called as a tool path. Under a tool path, if I click it, you can see that the 3D model of the blank is ready. And now if I go to this NC program, so you can see the NC program here. There is a black arrow strip mark. So if I click on that one, it will ask where to save that file. So here I will browse it and I will select under a desktop. Under a desktop, there is a Cim Lab. I have created a folder. I'll say OK. And under that, I will give some program number. It can be anything. So I'll say 5, 1, 2, 3, 4, 5, and I'll say OK. And here, if you want, you can give a name, or you can say just edit. So if I click on this edit, the program will be written here. So this we call it as a the CNC program that can be fed to the control system. And once this is fed, this program is fed to the control system and start the CNC machine, it will do the operations as per the operations that are sequenced in this program. And this, there you can see some of the codes, like we call these as the G codes and M codes. So G codes stands for the geometric codes, and M codes stands for the machine codes. And also there are some different notations for representing the different feed rate, rotation rate, and RPM and all. So that can be handled separately in different sessions. Now just you see that here I want to emphasize that a NC program will be created, and that NC program will be stored as a plate1 dot program, and you can save this file as a Word file, and you can take this program to any of the system. So I'll save it as plate1 dot Word. So now I will close it, and if I go to the folder there, here there is a plate1, and if I open it with a WordPad, you can see that the same program will be appearing. And this program, this we call it as a CNC program, which is generated by the software. Okay, so I will close it. Then we will go back to our model. Now I want to simulate this. So once now the NC program is created, once it is done, I have to check whether the tool paths what I have done is working in a right way or not. So for that, there is a play button here, green arrow mark, which is saying that start simulation. Click on this and you can see that a tool path that is moving. Okay, so now the drilling is done. Can you see this? So once drilling is done, so
Yes, sir.
you can see that the second operation, the third operation comes in now. It is called as the rimming process. Okay. So what we have done, we have defined 3 operations. One, face milling. Second, drilling. Third is rimming. So once this is done, so our programming is done. So with this, the first program is completed, and I will upload this video onto the Microsoft team. You can view at any point of time. And what I suggest you people is you take the software, get installed on your system, laptop, and try to practice the things. And in every week, I will solve each of these programs one by one, and if possible, I'll try to create these programs initially and just upload all the files onto the Microsoft team, so you can view at any point of time, and don't wait for me to come and conduct these labs every time. And whenever I send the link, just you log into the link and just view the videos and close it. Okay. So once I will just stop the recording. Wait.